Okay, should we get started? Or wait.
Just 1 second. Just 1 second. Just 1 second. Okay, we are live. So, good afternoon, everybody. We're really happy to welcome you to our first 2026 Her Path webinar from the Seeds of Success program. And I am going to let Latavia take it on from here. I want to welcome everybody who's joining on through Zoom and for the group that is joining on through YouTube Live. Okay, go ahead, Latavia.
Okay, hi everyone. Like Helena said, welcome to the Hope, Empower, and Rise Path webinar series. This series is a part of the Seeds of Success program. It's a program open to 6th to 8th grade students in the New Haven Public Schools. So today we'll hear from Dr. Marta Muñoz. She's a professor of evolutionary biology here at Yale. After her presentation, you guys can ask questions either in English or Spanish. If you're on YouTube, you can ask in the YouTube chat, or if you're on Zoom, you can either unmute yourself or type in the chat. So I will pass to Martha.
Thank you so much. Can I double check that everyone's able to see my slides? Excellent. Well, I'm so delighted to be here and to interact with you all. And I'm here to share a bit about my journey and about my path into science. So, I was born in New York City to Cuban parents. I didn't know I was going to be a scientist. My family lived through real poverty. And because of that, the value of education was never abstract in our household. It was about survival, mobility, and hope for a better future. Everyone in my family worked incredibly hard so that my sister and I could go to school and study. From a very early age, education mattered deeply, and for me, learning was never a chore. It was something I genuinely loved. My parents and family really hoped that one day I might become a doctor or a lawyer, professions that represented security, respect, and stability. But even as a child, I knew that those paths didn't feel quite right for me. What I did know very clearly was that I wanted to study nature. I didn't have the vocabulary for it yet, and I had no idea what that could mean as a career, but the pull was there from my earliest years. I grew up in a tiny apartment in Queens, New York. You can see my building with the red star on this map, surrounded by asphalt, concrete, and tall buildings. Living in New York City was a gift, and I really loved it, but there aren't many green places. So instead, I found deep joy in the small pockets of the city that could connect me to nature. Those places showed me that the world was much larger, older, and more complex than what I saw outside of my window. Looking back now, I see that this was the beginning of my scientific life. Not because I knew I wanted to be a scientist, but because I was learning how to observe, how to wonder. I was learning how to be curious, how to learn, and how to feel comfortable not knowing all of the answers. I didn't fully understand what that curiosity could become until I got to college in Boston. On the very first morning of my very first introductory biology class, the professor, Chris Schneider, gave a lecture on the Cambrian explosion. He talked about this moment in Earth's history more than 500 million years ago when animal life diversified in extraordinary ways. But what stayed with me wasn't just the biology, it was the sense of deep time. That lecture expanded my view of the world and my place in it by hundreds of millions of years back in time. It reframed my place in the history of life, and suddenly I felt connected to something inescapable, ancient, and ongoing. I remember sitting there, overwhelmed and honestly moved to tears. I remember that in that moment, I realized evolution was the thread that bound all the stories of life together. It wasn't just one topic among many in biology, it was the mechanism behind all of biology. So, to understand nature, I knew that I needed to become an evolutionary biologist. Evolutionary biologists were asking the biggest questions. Where did life come from? Why does it look the way it does? How do organisms change, adapt, and persist over time? I began my journey right there and then. Soon after, I began doing work study in a laboratory run by a young woman professor named Dr. Ayako Yamaguchi. For the first time, I wasn't just learning science, I was doing it. Together, we designed experiments, collected data, and asked questions no one had answered before. I still remember the thrill of seeing my first real data flash across the computer screen. Watching those numbers and patterns emerge felt electric. It was discovery in real time. At that point, the pieces came together very quickly. I could be a scientist. I could be a professor. I could run my own lab. I could make discoveries about nature. And I could devote my life to studying evolution. For the first time, my childhood curiosity, my education, and my future aligned into something concrete and possible. During this time, I explored widely. I was insatiably curious about biology. I studied neurophysiology, molecular evolution, immunobiology, host-parasite dynamics, and phylogeography. I wanted to try everything, to understand different ways of studying biology. A summer internship that I did in Indonesia turned out to be especially formative for me. Living on a boat, working long days on coral reefs, and collecting samples in the field solidified something very important for me. It made it clear that I wanted to be a field biologist. Being immersed in nature felt essential to how I wanted to do science. From that point on, fieldwork wasn't just one component of my training, it became central to my scientific identity. After years of living in big cities, I was finally able to experience nature in its place. I could connect directly with organisms, see them in the environments that had shaped them, and understand biology as something embedded in real places, not just in the lab or in books. I then went on to pursue my PhD at Harvard University, where I worked with Jonathan Losos, who is a wonderful advisor. What drew me to his lab was that his work sat at the intersection of ecology, evolution, and organismal biology, precisely the type of biologist I wanted to be. Graduate school was the period when many of the threads I had been exploring finally came together in a coherent way of doing research. A major focus of my PhD research included fieldwork in the Dominican Republic, where I studied mountain-dwelling anole lizards across steep environmental gradients. On a single Caribbean island, these lizards experienced dramatic differences in temperature, elevation, and habitat over relatively short distances, making them really ideal systems for asking fundamental evolutionary questions. But this work was meaningful to me for reasons beyond scientific research. Working in the Caribbean felt like I was going home. I grew up in a Cuban family in a Caribbean community in New York City. I speak Spanish, I share the same culture, and doing fieldwork there felt familiar in a way that really mattered. Doing research in Latin America and in the Caribbean specifically was important to me. It mattered to me where the science was happening and that I could make real connections with people there. Working in these systems also led to one of the core ideas that has shaped my research. What I learned was that organisms do not experience natural selection passively. Through their behavior, they can actively expose themselves to natural selection or even shield themselves from it. By choosing where to be, when to be active, and how to interact with their environments, animals can change the selective pressures that they experience. Those behavioral choices don't just matter in the moment. They can alter the rate at which evolution unfolds. This idea that organisms play an active role in shaping their own evolutionary trajectories through their behavioral interactions with the environment became central to how I think about evolution and about biology in general. By the end of my PhD, I had a clear sense of the questions I wanted to ask and the systems with which I wanted to work, and importantly, the kind of scientist that I wanted to be. Today, I have the joy of being a professor at a university, running my own lab, and serving as a curator in a museum. So, in many ways, things really have come full circle. But I could never have imagined this life when I was growing up. I simply put one foot in front of the other, followed the questions that mattered to me, and did my best with the opportunities in front of me. Looking back, what made the difference wasn't having certainty early in life about necessarily who I was going to be when I grew up. I ended up figuring that out along the way. What really mattered was that I stayed connected to what made me excited to learn, what piqued my curiosity. What mattered was to have persistence and a strong work ethic, to take every opportunity, big and small, equally seriously and put my all into everything that I did. To be insatiable for opportunity and for growth, and to be open to where my curiosity might lead. And this is true for many scientists. You don't need to see the whole road ahead, you just always need to be ready to take the next step. Thank you very much.
Okay, thank you, Martha. That was a great talk, very inspiring. I guess I'll first ask if anyone has any questions, or are there any questions in the chat? Okay, I have a question. So you mentioned that when you were younger, your parents were really focused on you being like a doctor or lawyer, maybe. Do you have advice for people or people who want to maybe branch out to different careers if their parents are like, I don't know what that is, I want you to be a doctor, lawyer, things like that?
Yeah, and it's very reasonable. I understand exactly where they were coming from because they were coming from a position of a lack of opportunities and real poverty, right? So in those circumstances, escaping poverty is the imperative. So everything that they did was to do that. What I did was follow my curiosity until it led to a career that would both make me happy and provide a pathway for financial stability. Those careers exist. I didn't have Google when I was growing up. Okay, I'm old enough to go back to the pre-Google days. But now you can use the internet to learn a bit more about what kinds of careers there are out there, depending on what really makes you interested to learn. I think if you follow with what makes you passionate to learn, what really piques your curiosity, whatever you do end up choosing, you'll pursue with your whole heart, right? So, in that sense, you will already be successful. And I'm sure that depending on wherever your curiosity lies, you'll be able to find a career that can make that possible for you.
Yeah, I agree. I'm in physics right now, so I feel like I also started out like I don't know what the careers are, but this is what I like, so let's see where it can take
Mhm.
me.
Yeah, and when I started in science, my parents were a little concerned. They didn't know what that looked like. They didn't know what the job prospects were. But at that point, I was in the university. Basically, I went to college and never left. I'm still in the
Yeah.
university environment. I saw people who had, all of a sudden the exact job I wanted to do. And I knew that it would provide security. And so I think I just needed to talk to my parents and share what I had learned by being immersed in an environment where I could see a stable career ahead of me, one that would also make me happy. And
Nice.
ultimately, even if they say you should be a doctor or a lawyer, your parents want you to be happy.
Yeah, very true.
Does anyone on Zoom want to ask a question? You can unmute your microphone. Nope, still a little nervous. That's fine. I have a question. So I noticed that you mentioned that you got an opportunity to study in Indonesia, and I kind of wanted to ask, can you tell me about more about how does one find opportunities like that? And is that more of kind of word of mouth that someone mentions it to you and then you go after it? Or is it
Mhm.
you kind of look at to it like literally Google some things or pre-Google, maybe just look up some books or talk to some other people? And also like how was the experience going to another country? Were you like scared at all to be away from your family? How does that like a little adjustment period and then the wow factor of being there and being able to continually do science and see the difference between the science that you do there versus like what you do here? Because I know sometimes it's a little bit different how people conduct themselves.
hmm Those are great questions. So the first question, how did I find out about this? Word of mouth. Talk to people, find your community of like-minded nerds and geeks, and word of mouth. So building your community of people who have shared interests, the more people you know in the field that you're interested in, the more word will just get around to you. And this was true, even before we had the same access that the internet provides. Now, by college, this was shared with me by email from a colleague and said, "Hey, this seems like something you might be interested in." I was like, "Yeah, you think?" And also at the university level, internships are often centralized by majors. So if, for example, if you were to major in ecology and evolutionary biology, which is my home department here at Yale, the undergraduate association collates these sorts of opportunities, provides them, and makes them accessible. So get yourself out there, get on mailing lists, get yourself in connection with other folks because these resources are available. Indonesia. Indonesia is very different, which is exactly what I was hoping for. It's tropical. I had wanted always to go to the tropics. And it hosts, I think, some of the most stunning coral reefs in the world. The Indo-Pacific is the crown jewel of marine biodiversity in the world. So, imagine I had, grown up in New York City, then moved to Boston, and suddenly I'm scuba diving on a coral reef in Indonesia. So, and I really liked, I mean, I also grew up in New York City, so being around people with, different backgrounds, different cultures, that wasn't uncomfortable for me. I actually really liked it. I wanted to try all the food. I wanted to meet people and make friends. I loved every minute of it. So for me, it was a privilege, And I think it's something you could only do at 20. I'm not sure. I think my days of sleeping on a small boat might be maybe a little less of that. But at 20, I couldn't get enough. I would have gone out and done the expedition all over again.
I see the same spirit between me and you in that I am 100% all about different cultures and just wanting to try new things. I love experiencing new cultures through their food and see how they do things. But yeah, definitely their biodiversity of just like all of the nature you have around is just amazing, especially in
Mhm.
different countries. So I'm so glad you got to do that because that sounds amazing.
It really was. Half the team was US based and the other half of the
Oh,
team was Indonesian, and we all lived on the same boat. We all, worked together. It really was a collaborative project, and I think that actually made it more fun to hear about Indonesia from a local's perspective and see things that I couldn't see as a newcomer.
yeah, very valuable experience. Thank you for sharing that.
Martha, I have a question for you. So here we have a large group of students who are in their last 2 years of middle school, so sixth and eighth graders between
Mhm.
11 and 13 years of age.
Mhm.
And they are all here because they like STEM or some parts of STEM.
Mm.
Um, what things at that age do you think kind of like led you in the direction that you finally took? Like, were you, did you ever struggle with like difficult classes? What kept you like on the path? Like, what kept you inspired to keep doing what you were doing?
That's a great question. So, um, in terms of connection with their interests, you live in New Haven. There are places in New Haven. This is actually a great city in which to grow up. There's a lot of access to STEM in this city. In fact, my niece and nephew are on the YouTube for this call. And recently, a couple of months ago, I took them to the Peabody Museum so that they could connect with nature, even though they were in a city. So it depends on where your interests in STEM lie, but New Haven actually does provide a lot of resources, many of them free, for you to learn more about STEM. Um, Classes. I always like to learn. Some classes were just naturally more fun for me than others. I remember in middle school, I enjoyed my science classes a lot, but I sometimes found my history classes a bit of a drag. I loved English classes. I loved to read and write. So some classes I liked more than others, but I knew the importance of doing well in my classes, of studying hard and applying myself. So whether or not, I was 110% in or maybe 95% in, I did my best.
That's great. I bet they had a very interesting visit to the Peabody Museum with their aunt telling them a little backstory on everything.
Yes, I took them behind the scenes to the research collections. What you see in the museum is a tiny, tiny fraction. We have millions of specimens behind the scenes that we use for scientific research. So I think that was the real fun, is to see what happens, behind the closed doors.
That's great. That's great.
I have one question. So we know a lot of these students are like in middle school heading to high school, and I know being at Yale, a lot of the labs here like welcome high school students like to work in their lab for a summer. So how would you recommend a student approaches maybe a professor to maybe work in their lab for a summer or something like that?
So I think, the easiest way is by email. I think the opportunities in lab vary according to the safety regulations of that lab. So labs, for example, that have live animals may have more restrictions than labs that don't. But that's something you can't really Google. You just kind of have to email the professor, and inquire. So we are approachable. Always feel free to email. And even if we can't offer a position in our lab, we can usually point you in the right direction.
Yeah, I know my lab, I think we do a couple of high school students every year from like freshman to senior. So I think that's definitely a good way to like get involved in the sciences if you guys are interested.
There you go. And once you get to college, then the whole world of internship and opportunities open up.
I have another question for you, Martha. So, part of what the students are doing is something called the STEM Ambassador Project. And this very important part of the program is to let them know that even though scientists have this bad rep of being alone in their lab, like not socializing with anybody, it's actually quite the opposite. Could you give us some examples of how you connect with the community and how, that feedback of your job and your discoveries and the community that you're involved in?
Interesting. It's so fascinating that you bring that up, because I also grew up thinking, scientist was this abstract idea of a, genius in a tower working alone, to create answers. And that's really not how it works ever. Science is collaborative, right? We don't all have all the skills necessary to answer questions. We have to build teams. And any space where you bring in more people and more perspectives will naturally broaden the scope of the questions we can ask and the insight that we're able to derive. So I don't, do science on my own. I have a lab, and that lab isn't just people doing what I tell them. That's actually the opposite of how it works. I bring in people who have shared interests, and together we develop projects, to answer certain questions. So it's by nature, just the lab environment itself, it's a collaborative space. Then we have all these colleagues across the campus and other campuses. We have ways to connect. We have conferences. We have symposia. These are all ways in which we create the setting for folks to get together and cross-pollinate. Conferences are where I make connections with people I didn't know even existed, before, or folks I had been intending to meet for a long time and really want to find a space where I can talk to them. So conferences are really great in that regard. One of the postdocs in my lab, we met at a conference in Ecuador in 2017, the Latin American Herpetology Conference. And he's been in my lab pretty much ever since, and if it wasn't for this conference, how would that have happened? He was a PhD student in Mexico and I was in the United States. So without a conference, that setting in which we would have naturally just found mutual interests, sat down over coffee and just talked about science, that would have been very challenging without that. Another setting, I mean, in the specific case of my work, is all the field work that I do. No matter how much I learn about the organisms, I won't ever have an insider's knowledge of those systems. So, what I've done in the Dominican Republic over many years is cultivate partnerships. Folks at the museum, local naturalists, people at the university. People have been working with those organisms and living in that setting usually their whole lives. And it's not just extractive, like I have a question and you give me an answer. It's how can we work together? How can we put our heads together and combine what I'm good at, what you're good at, and do better science together? So yeah, and I don't think this is rare. I think this is actually the norm. People get together and collaboratively do science.
Oh,
Thank
I have
you.
one more question. Is that okay? All right. So I know sometimes students might feel like if they aren't good at math or science, like in middle school, maybe high school, then STEM is just not for them, that they won't make it in college, you know. What advice would you have for people who may feel like discouraged because of where they are?
Mm, that's really important thing to bring up. I'll also mention that so young people are very self-critical and will self remove themselves from a space because they either through combination with societal pressures and maybe also a little internally may feel like they don't belong. And I think that is actually especially true for young girls. Young girls in particular are much more self-critical about their STEM skills and their quantitative skills and are much more likely to self-exclude. So there a lot of that has to do with historical societal biases. So I just want to point out that this exists in a space that existed before them, or this is occurring in a landscape that existed before them. And so they're inheriting a lot of societal baggage that we need to work to undo. Um, as long as you care to learn and you care to try, you can get wherever you need to go, right? So, in my opinion, there are things that I found more challenging and things that I found less challenging. Some things I had to work harder at, and some things that came more easily. I didn't quit on either, right?
Dice,
And
¿verdad?
sometimes I wanted to quit.
Abandono.
Sometimes I wanted to quit or I thought about it. But it's really about maintaining persistence, right? Um, you will find people who believe in you along the way. You may even encounter people who don't believe in you. I certainly had individuals who didn't personally believe in me. But if you believe in you, then you can weather the ones who don't and you can focus on the ones who do, right? So I think that's really important. And I think it's especially important for young people at this young, tender age, never to self-exclude themselves from something.
I second that with a very hard second. As a person who's also had to deal with that, of some people who did not directly told me to my face that they did not believe in me, I have since proved them all wrong. So I hope the rest of you also prove those people wrong.
I share that too, but I also think, what if they didn't even take up a neuron's worth of electrical firing and we instead just focus on the ones, on making proud the ones who knew that we had it within us?
Yeah, I'm gonna share like Ayana. Ayana, I also encountered that growing up uh, during my engineering career, that most of the professors would question why I wanted to get an A or why I wanted to redo the test to get more points. Like they're like, like, what are you gonna do with this? And I'm like, I want to graduate summa cum laude or whatever. And they're like, oh, so yeah, you let them know what you want. I think that's a good approach to don't self-exclude. I love that sentence, Martha. Thank you for that. We'll keep reinforcing that on our end.
Okay, there's a couple of questions in the chat. First, what are the classes should students take in high school to do science?
Mm. Uh, really apply your focus to your STEM courses. And if your school offers AP classes, advanced placement, try to take those. Even if you don't end up transferring the credits to college, you'll get in on a stronger foot because you will have had some background in those subjects. So don't be afraid to really challenge yourself. I feel that I went to a very science heavy high school. That training really helped me when I got to college. I didn't start from ground zero. So immerse yourself as much as you can in scientific classes and don't be afraid to be aggressive and take higher level scientific classes.
I agree. I took APs in high school and I had to skip like I think 4 classes in college because I had the AP credit, so it's really nice.
I did too. I used those credits and I graduated a semester early and saved some
Yeah,
bucks.
yeah, very nice. Also dual enrollment. I don't know if every high school has that, but I think that's a thing to do.
My
Um,
daughter also took a bunch of AP classes during high school, and now she's using the time to have a minor, to have a major and a minor. So she is complementing her major with other classes that she wants to take as well, that are not necessarily core classes for her degree, but are, you know, something that she also wants to learn. So
This is a very important topic that I don't think gets spoken about enough. Um, I had the great fortune of AP, but I also realized early on in my undergraduate that even though you had a certain set number of credits, you could overload and you didn't have to pay a dollar extra. And I just thought at that of that as like more education for free, basically. So I overloaded and I took humanities, culture and civilization, writing, and I just expand. I said, I want to learn about science, but this is my chance to take, broader classes about the world and learn, about the classics and about literature and how to write better. I think as scientists, we think that our improvement lies solely in honing our scientific skills, and that may be true, but it's not just that we should be doing. The ability to be a really well-rounded scholar, which if you're a scientist, you're a scholar, depends on your ability to think across disciplines, right? To communicate to people who are not directly in your field. All of those skills, and to put your science in the context of the world itself. Those skills are enhanced when you invest in a liberal arts education and you try to broaden your knowledge base. Time spent learning how to read and write better, how to communicate better will pay off for the rest of your career, no matter what specific subfield of science you end up pursuing.
and I think he also talks about the importance of being balanced, right? Like we're scientists and we're doing these amazing discoveries and changing the world, but at the same time, we have time for our hobbies and we are a bigger person than just what we are putting forth in our lab. So that also, with the classics and the reading and, all these things balance our lives and like you see, make you see even your science through a different lens and
Mhm. That's right.
have more well-rounded questions, answers.
Definitely. In high school, I raised four lambs and two goats while I was going through high school.
Were you
And
4-H?
yeah, FFA actually. Um, but yeah, I did that in high school, and some of those skills I picked up actually works, like especially all the heavy lifting, because I used to carry around a 66-pound goat, and that comes in handy very with like packages come very, very handy. So you'll never know. You never know. But
I
we
went
have
to high
another.
school in the Bronx. We had very different high school experiences.
Well, mine's from Texas, so that helps explain a lot. But we have another question in the chat. Someone asked, what classes are difficult in high school? I think that's very dependent on who you are, but we may have a consensus. Who knows?
Yeah, I mean, one of my favorite classes was organic chemistry, which most people I've learned hate, and I really loved that class. I thought it was so trippy to figure out how, molecules interact in space and how electrons will be shared. I mean, I thought it was really fun. It was like puzzle solving. And the class I liked the least was government and civics because I just felt like I had to learn a bunch of rules and the rules didn't make sense and they weren't clearly worded. And I worked my way through it, but it was not the most fun for me.
And now you get to read the grant application wording for everything.
And
So I don't
now
think
it's
you
nothing but
escaped it.
bureaucracy and and layered rules.
Mhm. Feel free, anyone, if you want to unmute and ask questions too. You don't have to always go through the chat. Come on, we want to hear your voices.
there is one new question. They say, can you do bad at school and still be a good scientist?
Mm. I want to pause at how that question was written. Um, I think by bad at school, the person is probably asking if your grades weren't as good as you would have hoped or as high as you would have hoped. I think that phrase bad at school already puts in that person's mind where their capacities lie. And I think maybe let's push back against that. School is an opportunity to learn, and every time you do a new grade or you enter a new environment, it's a new opportunity. So, not everyone starts from the same place. People may have different learning strengths and areas of growth. I've seen a lot of folks, who didn't quite work things out the way they wanted. And maybe they did a bit more schooling early on, or maybe did a school from which they intended to transfer later to a four-year institution. There's many pathways that people take. There's no single pathway to being a scientist. And doing good, doing well in school and being a good scientist aren't necessarily the apples to apples that they may sound like, right? So, being a good scientist, let's talk about that. So, I wanted to just address the idea about being bad at school. And I really think that that's more a question about trying and about self-belief. And maybe that's a place to start with that. Let's move on to the second part of what it maybe takes, what is required to be a good scientist. So, to be a good scientist, you have to be curious. You have to know what's already been learned about a subject. So, if you're interested in something and you think it's super cool, you have to sort of do the work of figuring out what everybody has already figured out about it. What is the base of knowledge on that question, that system, whatever it is? And then you have to learn the skills that you need to answer questions about that system, right? So that just takes hard work and putting yourself in an environment where you can acquire those skills. Another really important part of being a good scientist is having self-doubt. Another stereotype that you see about scientists is that we are very, very confident, that we know the answers, that we're certain about things. I actually really question when people speak with incredible certainty, especially about scientific topics. I want to clarify that I don't mean self-doubt about you, the individual, and your capacity to do the work. I mean self-doubt about, did I answer this question from every possible angle? Have I thought about all the things that I could do to answer this question? Is there someone else who's an expert on this that I could be talking to? Have I done everything I can to really answer this question? You see today in the media a lot of people speaking with certainty, and sometimes scientists actually lose, I think, unfortunately, credibility when they do speak with the natural self-doubt of a scientist. We speak in terms of probabilities, likelihoods, counterfactuals, alternate scenarios, because that's the nature of the work. And you're up against sound bites that deliver certainty. And I think people want to gravitate towards certainty. But the reality is much more complex and nuanced. And so I think being a good scientist is embracing the chaos, embracing the uncertainty, and doing your best at all times to make sure you've done everything you could to answer that question and build the community you need to bring the expertise you can. So it's also about community building.
Yeah, I agree. Definitely do not let grades stop you from working to be a scientist, you know?
Hold on, I have a story about this. So my first PhD student did not have a very good GPA in undergrad. Okay. And she felt very self-conscious about this. But I could tell from my interactions with her that she had what it took. I could see curiosity. I could see a very hard work ethic. She had published some of her work from undergrad, which shows that she really does care and put enough effort into, getting a project from start to completion. All of the ingredients you look for in a scientist, I could see in her. But because she didn't have the grades, in her mind, she was self-excluding. And she felt, that it was the concessions were being made to make space for her, when it was actually, in my opinion, quite the contrary. I knew she was going to be a killer grad student. I knew she's a killer scientist. She recently won a very high prize for young investigators in the field. And she did not have good grades. So any of you who think that just because you don't have the grades you think you want, you can't be a good scientist, my first PhD student is living proof right now that that's not true.
Yeah, and that's also why when you apply to college and grad school, they don't just ask for your grades, they ask about what you do outside of school. They would know who you are as a person.
Hmm. I mean, do your best. Good grades help. They are an indicator of performance in courses, but it's like one of many things we consider. And honestly, if you have everything else, who cares about, having straight A's? Often, students are facing real constraints. Sometimes they have to work to get through school. Sometimes things are going on that are outside of their control. Sometimes students have a growth trajectory. We're not all, there's a greater open-mindedness to the whole package than people probably think.
So I have a question. I guess in high school, all the sciences can feel really separate. You have biology, physics, environmental science, things like that. How would you encourage students to kind of um, understand like how interdisciplinary all the sciences and math and things like that can be?
Mm. Well, one of our departments here at Yale is molecular biophysics and biochemistry. So that interdisciplinarity arises in higher education institutions where entire communities are built around them. Um, our department is ecology and evolutionary biology because we feel those two disciplines, while pretty different, actually kind of belong together. That interdisciplinarity, I think, comes out in the process of continuing to move through academic spaces. I think they are taught separately because at the pre-college level, there are certain fundamentals for each discipline that are really important. Without those fundamentals in place, it's hard to integrate across systems. So I think the intention is to give you a foundation of knowledge, the sine qua non of chemistry, of biology, of physics, and then hopefully the goal is once you have those foundational pieces in play, you are capable now of, thinking about questions or uh, building interdisciplinarity that sees insight about the complementarity of fields that's greater than the sum of the parts, right? That comes once those foundations are in place.
I agree. I do physics and neuroscience, and I didn't have an idea of how these two things could be combined until like my third year of college.
Okay, there you
So yeah,
go.
definitely.
But
Yeah,
how much physics and how much neuroscience foundation did you have to build to be able to get there?
yeah, yeah,
Yeah.
exactly. Okay, any other questions? I know I'm kind of asking a lot. Oh, okay, here's one more. Did you ever feel like giving up or doing something else?
No. I had a pretty good sense of who I was. And I don't know, maybe it's being from New York. It was, stay out of my way. I was gonna do it. And I had a very good and loving, supportive family behind me to support me. So I had a good community to keep me motivated. So I knew, I didn't know what that career was precisely, but I knew who I wanted to be. And I had a very strong sense of self. And I just needed a space to be able to find the vocabulary for who I was. And that took until college. If you know you want to be a physician, that's, a lot of people know about that career. Maybe you figure that out earlier. Or maybe you think you're going to be a writer and then you decide you're going to be a physician. There's no single pathway. I happened to figure mine out in college, but I still had a sense of who I was.
I would say always be willing to go with the flow or pivot. So if you're not as confident as Martha is, with some people aren't, and she was, by all means, go for it. You did what you did. I'm so proud of you. But for those who don't, just always be open to go with the flow and sometimes pivot to something new. Because I originally had my major was biological, agricultural, in what was it? Now I can't remember, but it was like some type of agricultural engineering, biological agricultural engineering. That's what it was. And clearly I'm a biomedical engineer now. So clearly a pivot happened in between those two majors. So I did do after that. And then now I have like this amazing little career and everything like that. And I'm so happy because I actually figure out I like what I do now a lot more. And I've not pivoted or just given that leap a faith, then I wouldn't be here where I am now. So it's okay if if you end up into something and you're like, you know what, this really isn't working out. I don't really think that I like it. It doesn't mean that you have to stay there. You can go somewhere else, and don't be afraid to go somewhere else. Sometimes you got to start over a little bit or close to a little bit to the pathway, but don't ever let that stop you, because I promise you're going to end up somewhere you either didn't know existed or somewhere you didn't think that you would enjoy so much. So definitely don't be afraid to pivot. Don't be afraid to go with the flow.
Agree. And even though I had a sense of what I didn't want to do, I still kind of had to pick a career, even though I hadn't figured out what a scientist was. And the closest thing I could think of was to be a wildlife vet. I thought that would get me into nature, right? And so that was the only career I even knew about before the age of 18 that seemed close enough to what I wanted to actually do. So the pivot was like, oh, wait, I could be a scientist and a professor and a field biologist, but let's do that. So even though I knew who I was still willing to pivot when something like you found something that was closer to your heart and you knew once you found it was right, feel free to pivot.
Okay, so we have a few minutes left. I wanted to encourage anybody who has a question to go ahead and ask it. It can be out loud, it can be on the chat, it can be from the people that are watching us via YouTube. Let's see, in the meantime, Marta, what has been the craziest thing that has happened in your lab? Like once one of those stories that you're like, you're not gonna believe this.
You mean the time it flooded?
Maybe tell us about it.
Um, one of the sensors in we have animal chambers where we have salamanders and lizards, and we maintain very tight humidity and temperature. And I think one of the sensors went off and it just triggered the fire response, even though there was no fire. And so just like buckets and buckets of water came down. We were able to get in quickly and like resolve it, but yeah, there was quite a bit of water in the lab. Yeah, things like that happen. You gotta, what did Ayana say? Go with the flow? We went with the flow literally and figuratively. We figured it out.
With the flow, with the flow.
Yes. Yes.
Would you change anything if you could go back?
That's a good question. I think I would have asked more questions. I think maybe my science teachers and other teachers that I interacted with might have known things for me to pursue if I had known how to ask them better. And I'm not saying I didn't figure it out. I found my own path, but maybe I would have gotten there sooner if I had asked more questions.
And on that amazing note, I think we're going to stop the questions. But it's so important. This is something that, the Seeds of Success team and mentors continually tell our participants, that the one thing that scientists are always doing is asking questions. And we are always letting them know that we are available to answer them. And sometimes we might not know the answer, and then we'll get back to them. And that is part of the job and part of the amazing journey of discovery and learning. So, Marta, I want to thank you so much. This has been amazing. I think that you have shared not only important information about your career and your trajectory, but about your life as a scientist and your road to who you are today, being a woman, being Latina. This is just so much wisdom that you are sharing with our students. I also want to thank Joanna and Ayana and Latavia for being part of our Her Path webinar. And and I want to thank all the students from Seeds of Success. Thank you so much for joining. Extra clapping for the brave ones who asked questions. And if anybody else has any other questions, email us. We will forward them to Martha, and maybe they can, Martha will find it when she has the time. She'll answer them and keep sharing her knowledge. And with that, I'm going to sign off. This video recording is going to be available together with a little activity on our website, and we'll share that with you a little bit later. Thank you very much, and have a great afternoon.
Bye.
Thank you.